So here's what challenges look like these days. I'm working on these control panels, or on the electronics and the electrical for this vehicle. And so this box is going to be for power. So battery chargers. I've got this small charger that is going to charge this battery. So this battery is going to be in here, and this charger is going to hook to it. You'll be able to plug just a 3-prong cable into the side, and that's connected to the charger for the 48 volts over here, and this is the charger for 11 volts right here. I'm going to get into all the voltages soon. Back here in this box is the Arduino that's going to control the steering. So this first it's going to control steering centering, and it could control the brakes. I don't need it to control the brakes, but I want to do some tricky things with it so that I can use this to modify the signals. These are relays that are going to turn the power supply on. So the power supply needs to have this yellow wire here, this small yellow wire. It needs to be powered for this to turn on. So what's going to happen is this relay is going to turn the power supply on. This relay is being controlled by the Arduino. So I'm going to write in the code for the Arduino, one of the very first lines is, if you don't have a radio signal, a good radio signal, because the receiver somewhere is going to, the radio receiver goes here, and it's around someplace, but this is going to be talking to the Arduino. And if the Arduino doesn't see a signal from the radio, then don't power the power supply on. So what that's going to do is, if somebody turns the battery on this machine and powers it up, and they don't have the radio on, then I would hate this to get some sort of stray signal. You always want it to have a good quality signal. This one thing about the speed controller is it can run on so many things. It can run on pulse signals, serial signals, analog signals. It can all kinds of things you can do to this to make it turn the motors. I'm using pulse because that's what the radio uses. But with so much magnetism around, with big motors and big power in the battery pack, I want to make sure that this doesn't get any kind of stray signals and take off without the radio being turned on and being out of control. So this is going to control like a neutral start, if you will, a neutral drive. It has to see a radio signal first. This is the boron that's going to have this is the cell phone connection. It's farther down the list. I'm just, trying to get all the devices in here that have to be in here so that I know whether everything's going to fit, right? So these 3 devices I've got in here so far, I still have to put the Pixhawk controller. It's probably going to go here because it wants to talk to the speed controller. All the speed controller wires are going to come up through this hole. So there's going to be a harness where all the wires come up, and so you'll have all of the interface with this will be done in this box. But the problem I'm having now, the challenge I'm having now is this box up here. So let me explain. The steering motor, which is going to sit right out front here on the device when it gets installed, the steering motor will be here. It wants 12 volts to run. So there's 12 volts. There's 110 volts in the box, and this is the 12 turning. When you turn the key on, here on the outside there's an ignition key now. It turns this on and turns all the power on to everything. So everything here is dead until you turn this key on. So 12 volt, this battery, I wanted to put a 12 volt battery up here, but the problem is 12 volt batteries are lead acid. Well, lead acid batteries are typically 12 volts. And to get kind of any endurance for the steering motor, I don't want it to go dead halfway through a drive. So I don't know how much power it's going to take, so I wanted to have enough. And that ends up being a very large lead acid battery that sits in here. So I've switched over to this lithium pack. This is out of a remote control vehicle, like a quad or a remote control airplane or something. And this, because of the voltages of lithium, this ends up being 11 volts, not 12. So all it's going to do is steer the front steering just a little bit slower. I think I have lots of speed enough. I think I have enough speed in the steering already that 11 volts instead of 12, or 11 point something instead of 13, probably isn't going to make much difference. I'm thinking it's still going to steer quickly enough. And the fact that I can save so much space with this much smaller battery, and it's lighter, but that doesn't really matter on this vehicle, but it's going to save so much space that I can also put the charger for it. So this charges through these small wires here on the battery. So this will plug in. This gets wired to this plug. So when you plug it in, this battery gets charged, and the big 48 volt battery, the drive battery, gets charged from this circuit here. These two wires that come off of it right here run a cooling fan, and I've installed the cooling fan here. So this, let me show you how this looks. This is the top of this box. So here we have two servos, and this is actually backwards. So two servos going to run the brakes. So the cables from the front brakes come in here, and one servo turned out not to be enough. I don't think I had enough. The brakes still wouldn't completely come on. So I installed a second servo, and now I've reconfigured this block a little bit. So each cable is going to come in and it's going to be able to get pulled by each one of these servos. Will pull its own brake. So now I can actually operate the front brakes independently of each other. I can hook them up so they both operate together. So if I do maybe move the left lever up, both brakes come on. But I think if I put the code for those through the Arduino first, I can measure the signal coming from the radio. And hold on, let me get the radio. So this radio is going to send a signal, and I'm going to use this lever for the brakes. So it's spring centered. I have it set up so it's spring centered. So if you let go of it, it comes back to the middle just like this one. So this is going to be throttle and steering, and this one is going to be brakes. And what I would like to do is, if I move the lever this way, it only applies the left brake. If I move it this way, it only applies the right brake. If I move it this way, I want it to apply both brakes. So I can do some mixing of these channels within the radio itself. There's a menu in here that you can go into, and you can mix two channels together. I don't think I can use mixing here because this is one channel. Side to side is one channel. So I need to know if it goes from 1500 pulses down, or pulse length if it goes down, then I want only one channel here to operate. If it goes from 1500 pulse length up, then I only want this one to operate. These are two completely different circuits. This is one channel. So I could make it do this and operate both of them at the same time. That's not a problem because I could just fasten the two wires together to do the exact same thing. But I would think I'd like to run it on two channels because the rear axle of this thing doesn't have a differential. And I think if I want it to steer quickly for some reason, to be very maneuverable, I would like to be able to put each front brake on individually. So I would just just have this signal go into the Arduino, and the Arduino is going to say, okay, if it's above this number, then do this. If it's below that number, do that. And I can now, tweak this or custom design this to run these independently. So that's high on the list. This lid gets fastened down by these latches. So I got all the latches installed. So this is, it's a very good secure setup here. This lid now has the fan built into it that used to be in the box around this. And that fan sits right over top of the heat sinks. So when the circuit's going to be the same. When you start the battery charger going, this fan is going to blow air down through this grill onto the heat sinks, and it's going to pressurize this cavity, and it's going to vent out here at the back. So hopefully it won't be warm at all, but hopefully you'll be able to feel the air coming out here just to keep the air circulating inside this box to make sure that nothing heats up more than it's supposed to. So this is power for steering and battery chargers for drive and steering battery. The challenge becomes these servos they're not good for 12 volts. They're good from 5 to 7 volts. So I need a different voltage for these. When I hooked them up first, I have hooked them up to a power supply, and it seemed like the one wanted to take like 4 amps to run one. And the buck converter that I bought for this thing, I bought a little automatic converter. I don't see it here. It's adjustable for 7 volts, but the problem is at 7 volts it doesn't have enough current to run 2 of these. So I think the current will top out, and when it tops out, these servos release, so the brakes come off. So I would be worried that it would max out on current and the brakes would be released at the wrong time. So they'll handle from 5 to 7. I have here what they call a buck converter, a DC-DC converter. So this one is good for 12 volts in and 5 volts out at 10 amps. This would be just barely enough power to run the brakes. I would love to run them at 7 volts, but nothing here is 7 volts. This goes from, well, this one goes from 48 to 12, and this one goes from 12 to 5. So I could put these in together. It starts getting ugly. There's too many pieces inside. So I would love to try to find something that is either going from 48 right to 5 at 20 amps, something heavier duty than this. And I hate to buy one because I have so many of these things kicking around. Or I can get a 7-volt battery pack that'll run this, but now that's another charger in there to charge at another voltage. So, 48 volts for the drive, 12 volts for the steering, 7 volts for the brake servos, 5 volts for sensors and Arduino stuff. All the, so, and it's starting to get, I need to solve the problem of how to supply voltage to these. So that's my next challenge. A friend of mine is helping me writing code for the steering, so that'll be interesting. He's a professional code writer. That's what he does, and it'll be interesting to learn from what his code is. He sent me an example last night, and I'm enjoying trying to read it. It's written at a level way above me, but I'm enjoying trying to read what he's doing. So anyway, so this is what the bench looks like when you're doing this kind of stuff. There's stuff everywhere, but that's okay. That's what keeps it fun. Okay, till my next challenge.